In this lesson, we are going to start our work on trigonometry, or learning on trigonometry, and we're going to start with some simple ideas of an angle, putting an angle on a coordinate plane, and then moving towards the unit circle. So we're going to get some basic definitions and understanding under our belt. Now, an angle in geometry is defined to be two rays that share the same endpoint. So there you've got two rays and they share that same endpoint, which is called the vertex. Now, we're also going to look at an angle in precalculus as an endpoint, a ray, and we're going to call that our initial side. And the initial side is going to be fixed. And we're going to rotate that other ray about the endpoint. So we're going to take it and we're going to rotate that ray about the endpoint. And where that ray ends is going to be called the terminal side. And that's why over here it's called an initial side and a terminal side. Now your angle starts at the initial side, and then this little arc right here is showing you the direction in which the angle is going. So this angle is going counterclockwise. Now the end point is the vertex. So still the vertex right here. And then that rotating ray is this terminal side. So that's the rotating ray. The initial side is a fixed side. So in standard position, we're going to take that initial side and we're going to always have it start on the positive x-axis. So that's going to be our initial side right here, the initial side. And you can see that on the coordinate plane, I've labeled my quadrants, quadrant 1, 2, 3, and 4, just like we do in algebra. So we've got our initial side, and we're going to rotate counterclockwise. So we're going to rotate counterclockwise until our terminal side ends. So if our terminal side were to end right there, my arc that's going around from the initial side to the terminal side is going to have an endpoint, so that arc will start at the initial side, and then it's going to have an arrowhead that touches the terminal side. And that's how we're going to draw our arc. Now this angle right here is going to have a certain measurement that we're going to talk about in just a minute. Now this is called an angle in standard position. The origin is the vertex. So this right here is the vertex of your angle. So it's the vertex. And the initial side corresponds to the positive x-axis. The positive x-axis. So that's an angle in standard position. A positive angle turns counterclockwise. So we would call that a positive rotation or positive angle. And a negative angle would turn clockwise. For instance, if I have an angle that's in quadrant 1, and I start at the initial side and I end at the terminal side, that would be a counterclockwise turn, and that would be positive 45 degrees, about. If I start at the positive x-axis and I turn clockwise, so this was counterclockwise, this turn is going to be clockwise, going around like a clock. That would be 45 degrees. So that would be a 45-degree angle. Now that would be a 45-degree angle. We're going to talk about where that is on the unit circle coming up on the very next screen. So in the next video, we'll talk about how that is on the unit circle. But this is just an amount of rotation, just an amount of rotation, a 45-degree amount of rotation, a 45-degree amount of rotation. Did I say that this was 45 degrees? You're probably going, what? It's clockwise. It's supposed to be negative. That would be negative 45 degrees. Negative 45 degrees. Good thing I caught that now before the video ended, right? So counterclockwise, positive angle, clockwise, negative angle. We'll do lots of this. So the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. If I were to start at this initial side right here and turn this way, that would be 45 degrees shy of 360. That would be a positive 315 degrees. Now positive because you're going counterclockwise. 315 degrees because we've got 90 plus 90 plus 90, that's 270, and another 45 would be 315. So this location right here, this terminal side, I can go a short route, which would be clockwise, and call that a negative 45-degree angle, or I can go the long way, which would be counterclockwise, resulting in a positive angle, but that amount of rotation, and that's what I'm going to highlight right here, that amount of rotation is larger. This red amount of rotation is longer. It's a larger amount of rotation, so it's going to be a bigger angle. So with degrees, this should make some sense because we're familiar with degrees. But an angle can be measured in both degrees or in radians. So what is a radian? Now, the definition of a radian, just one radian, the definition of one radian. And then, of course, once you know what one radian is, we can figure out what 2 radians is, and then what 3 radians are. I don't know, I think I just said 2 radians is, 2 radians are, 3 radians are, 4 radians, and so on. So here I've got the center of my circle, and I just tried to make a little x-axis and a little y-axis, a horizontal axis and a vertical axis. So my initial side, remember my initial side is going to be the positive x-axis. So here's my initial side of my angle. Now in geometry, you learned that this would be called, if this was the initial side, we've got terminal side, we've got an angle. This in a circle would be called the central angle. So that's right there, the central angle. And I'm going to make the little angle symbol right there. So that's a central angle. Now, that central angle is about 60 degrees, right? So think of it about 60 degrees, about 60 degrees-ish. It's not quite 60 degrees, it's about 60 degrees, we'll say. In fact, I'm going to make it more accurate here. Here we go. So that's about 60 degrees. This, in radians, is going to involve this arc. So see this arc right here. If I were to take a string and I were to measure that arc, just measure the arc from beginning to end. The measure of that arc would equal, the measure of that arc would equal 1 radius. So I could take that string, that red string, I could measure out that arc, and from beginning to end, cut the beginning, cut the end, and whatever the length of that string is, I could take that same piece of string and stretch it out from the center of the circle to a point on the circle, which would be the length of the radius, and they would be equal. So the radius would equal the arc length. Now, if I were to move this angle, okay, if I were to move this angle and I were to make it over here, the purple part does not change, but the red part would. And if the red part is bigger than the purple part, so if that arc is longer now than the radius, I have more than a radian. I have more than 1 radian. So 1 radian is going to lie somewhere in quadrant 1. And it is actually going to lie just shy of the 60-degree mark. So that was why it was important for me to draw it the way I did, because it really is just shy of the 60-degree mark. So this right here, this arc length is the same as this. So my question is how many arc lengths, how many radians? So this turn brings me right here. If I take that same amount of turn, I'm going to have another red arc that would be equal to this arc, right? So if I have another angle that's equal to this angle, and I end up over here maybe, I'm going to end up with a second radian, and then I'll have maybe a third radian. How many radians all the way around the circle? Well, the answer to that is a little bit more than 6. So watch. Here's another one, right? I can just eyeball this. Here's another one, and then here's another one. 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 So that would be 1, 2, 3, 4, 5, 6. And actually, if we go all the way around, we would have 2 pi. And what is 2 pi? 2 pi is approximately 6.28. 3.14 twice is 6.28. So a little bit more than 6 radians all the way around the circle. So algebraically, and this is what we're going to be using for trig a lot. Algebraically, we're going to have an arc length. That's going to be called S. S is your arc length. And that's equal to your radius length. I'm going to use the same color here, purple, R times theta. Now, to use this formula, S equals R times theta, let's think about this. Your arc length might be measured, think about that string, it might be measured in centimeters. It might be measured in inches. So let's just pretend it's centimeters. So if this arc length is measured in centimeters, I'm going to have centimeters has to equal centimeters. So in order for that to happen, centimeters equals centimeters, I'm going to need theta to not have a label. And if I use degrees, it's got a label. So theta is going to be an angle in radians, because radians does not have a label that's associated with it. R is your radius length. So that's your radius length. Radius length. I'm very sorry that I'm running out of room here. And then S is your arc length. And that's the same letters we used in geometry for arc length, S. So theta equals, S equals R times theta. We can also write this as theta equals, I jumped a little bit ahead, equals S over R. So if I solve this equation for theta, I would divide both sides by R, and I would get theta equals S over R. So sometimes we use this form in gray, and sometimes I use this form right here, S equals R times theta. Let's talk very quickly about degrees and radians going all the way around the circle. So 1 full revolution, I'll call it a rev for revolution. So rev equals revolution. And then we're going to say 1/2 of a revolution. We'll say 1/4 of a revolution, 1/6 of a revolution, 1/8 of a revolution, and 1/12 of a revolution. So 1 full revolution in degrees is 360 degrees. Half of that would be 360 divided by 2, which is 180 degrees. 1/4 of a revolution would be 1/4 times 360, which would be 90 degrees. 1/6 of 360 degrees would be 60 degrees. 1/8 of 360 degrees would be 45 degrees. And then 1/12 would be 30 degrees. So those are super important angles going around the unit circle and measured in degrees. Now, again, degrees has a label, that degree mark. So if I were to use that degree mark here, I would have, for instance, centimeters times degrees. And there's no such thing as centimeter degrees or degree centimeters. That unit of measure just doesn't exist. So I can't use degrees when I'm doing certain computations, especially using this formula. I would need a measure of a rotation that doesn't have a label associated with it, and radians is it. All the way around the circle is 2 pi. So 2 pi radians is what we say out loud, but notice how I'm not labeling it. It's just 2 pi. Half of 2 pi is pi. 1/4 of 2 pi is pi over 2. 1/6 of 2 pi is pi over 3. 1/8 of 2 pi is pi over 4. And 1/12 of 2 pi is pi over 6. So if I went a little bit too quickly for you, number one, you can slow me down. 1/2 of 2 pi. Then I did 1/4 of 2 pi. Of is multiplication. I did 1/6 of 2 pi. That would be pi over 3. 1/8 of 2 pi. 1/12 of 2 pi. So that's where those values came from. So what that means is when I'm talking about degrees, I have 360 degrees. The equivalent in radians is 2 pi. And every 180 degrees is equivalent to pi radians. 90 degrees is the same thing as pi over 2 radians. 60 degrees is the same as pi over 3. 45 degrees is the same as pi over 4. And 30 degrees is the same as pi over 6. Now in the next video, we're going to talk about those angles around the unit circle. So we're going to look at the unit circle right here. So we'll look at the unit circle, we'll do degrees, and then we'll do radians, and we'll talk a little bit more about maybe estimating angles, determining the quadrants, this right here. So we'll see you in the next